Good evening to one and all. Warm welcome to you for this wonderful webinar session by BTR Construction Hero. Today our chief guest Dr. S. Govindharajan sir, working as a professor in Department of Civil Engineering, Aditya Engineering College Autonomous, Andhra Pradesh in India. He obtained his PhD from Anna University, Chennai in 2016. His area of interest in concrete structure and analysis and design of building structures using StatPro in research in concrete. He has published 15 numbers of papers in reputed international journals and presented the 14 papers in national and international conference. So welcome you, sir.
Yeah, sir, good evening.
Good evening, sir.
Good
Welcome.
evening, Mr. Udai. Good evening.
Good evening,
Good evening
sir.
to everyone. Yeah,
Good evening, sir.
yeah, good evening. Sir, shall I start?
Yes, sir. The
Pradesh?
stage is yours, sir. Please, sure.
Yeah, okay, sir. Okay. So, good evening to everyone. Myself, Dr. Govindharajan. Actually, currently I am working as a professor in Aditya Engineering College, Andhra Pradesh. First of all, I thank to my management for giving the opportunity to take the deliver lecturing for BTR construction. Okay, and once again, I thank to Mr. Uday Shankar for giving me opportunity for a wonderful for this in your construction. You give me that for lecturing delivery. Okay, thank you.
Thank you, sir.
So yes, sir, thank you. Today I go to deliver for the topic is for Indian standard from the structural elements from various in building by using from IS 456. Okay. Why I am selecting for this type of the topic? Because most of the students and the faculties, they will be studying in the classroom based on the design for IS 456. But when you come to the construction site, there will be lifting some changes are there. So that's what I in our class actually already I take the classes from in Aditya College. So in the students, I will say many number of the students they having many difficulties because they will be know that what is that design and how to deliver the design and how to deliver that from construction also. So that's what I am selecting for this type of topic. It will be very useful for viewers. Okay. So please everyone should maintain the silence. And if any doubt, the end of the section, I will clear everything. Okay. So thank you to everyone. Now I move on to the lecture for our topic. Okay. So thank you. Sir, shall I close that video? Then I will open from audio only. It is okay?
Yes, sir. Okay, okay, sir.
Okay, sir. Thank you.
Thank
Thanks. Okay. Yeah. I think it's visible from all of you.
Yes, sir. It's visible, sir.
Yeah. Okay, sir. So this is the topic I go to deliver for today. That is for Indian Standard Plain and Reinforced Concrete for the Code of Practice from IS 456. Okay. So now I move on from that one by one. Normally, your RC structures they having for different types of the elements like column, slab, beam, and finally they having for foundation. So the lab for the load will be transferred to the slab, then it will convert to the beam, then beam load that will be transferred to the column. Finally, the column load will be transferred to the foundation. This is the basic for you must be go from the design. Whenever you must be go for the design, you must be having for study all the structural elements. Okay, then only you must be go for the design. So normally in your reinforced concrete, you are using for IS 456. Not only for IS 456, when you draw from the reinforcement detail, that time your IS 13920, that is the code books also needed. Okay, because you want to make the draw from the reinforcement, you must be using that type of the code also. Okay, and another one more thing for SP16, for the particularly you must be designed for the column. Okay, so when you start from the design of any type of the RC structure, you must be having for this three type of the code book, right? for SP16, IS 456, and IS 13920. Then only you must be finished for your all the design steps. Okay. So here I given from all the type of the element like column, beam, slab, and foundation. And what is the thumb rule they will be using for the construction site. Okay, then only you must be easily understand. Because first I will start from what are the criteria that will be using from the IS 456 for different type of the structures. Okay, here first I will choose it from the column, right? So normally you must be study, you know very well from the column. The first criteria. Okay, when you want to design for the column, the first criteria you must be chosen for unsupported length. Here all I given in your IS 456. That's what I will mention here. Okay. Here already I mentioned here.
Sir, sorry for the interruption. The screen is not working, sir.
It is working. Sir, it is not working.
Only the main screen is there, sir.
Main screen. Column is there, na, sir?
Sir? No, sir. No,
It
sir.
is not
Only
working.
the no, sir. Only the first screen. Yeah, now it's.
Now it is okay.
Oh, okay, sir. Okay, sir.
Okay, okay, sir. Thank you, sir. So the first one.
Sir, another one. Increase the screen size also, sir.
Yeah, that is better, sir.
Yes, sir.
That is okay, sir.
Sir. You go for your function 5, and it will be screen will be large, sir. Automatic
Yes,
full
sir.
screen.
Now, 1 second, sir. I will check.
Okay.
Sir, this is okay.
Uh,
Yeah,
yeah. So okay, sir.
yeah. Okay, sir. Okay, now right. Okay, I move on to the first one for the column structure. So they're having for the first criteria, I will using from unsupported length. Okay, so here already I mentioned is from. Wait. Only 1 second, sir. I will
Oh,
exit
okay.
on marker because it will be helpful from all of you. That's what I will using this one. Right. Okay. So here I will take it from the first criteria I will using for the unsupported length. So I given from the three type of the structure with the column, right? Here I given as a flat slab, second one the flat plate, and another one is the column capital. The first one is unsupported length. You must be calculate. Okay, so how to calculate from this one? Your top slab and bottom slab you must be taken from in the top, bottom to your bottom slab. The top that will be the distance is will be called from unsupported length. So this will be using from the flat slab. You must be calculate for unsupported length. Already you know that what is the flat slab without any beam. Your column is direct. Your slab is directly supported to the column. Okay, so that is the function of the flat slab. So now we move on to the second one for the flat plate. So the flat plate they will be taken from the drop is there. So in the drop you must be having from the top, your top of that your bottom drop to your bottom, your top of the drop. That is the distance will be taken from unsupported length for the flat plate. When I come from the column capital, your unsupported length will be calculated from the distance between the bottom of the column width to your bottom of the slab. That is will be talked from your unsupported length. This is the first criteria you must be calculate for your unsupported length for the column design. Okay. And second one, you are already thorough very well about that effective length of the compression member. This one also in that IS 456. Okay, normally they having for different type of the end of the conditions. You must be selected for what is it your effective length from the different type of the end condition. Here they given from for various type of the structure with different end condition, and they given us theoretical value as well as recommended value. Okay, but in your design process you must be chosen for only this your recommended value. Okay, so you must be chosen for only the recommended value. So okay, the first one they having for the first conditions, your column having for the two end of the condition will be for the fixed. The top one is the fixed and bottom one is the fixed. That will be for your restraint for both position and from the rotation. Okay, so your value will be considered as 0.65 times of L. So you must be know that how to calculate for effective length of the first conditions. You must be chosen for that value. And second one, your bottom will be fixed and top only will be given from the hinged one. That will be the rotation will be taken from the top. Then you go to chosen for what is your recommended value, 0.8 times of your L value. Then again you must be go from the third one. Your both ends they having for the hinged one, so your recommended value will be taken from one time of the L, that is called from the effective length. Okay, this L is nothing but that is the unsupported length. Please note it
Sir,
down.
sorry for the
Okay.
interruption, sir.
Yes, sir. Yeah.
சார் அந்த எஃப்ஐ கொடுத்தீங்கன்னா அது ஸ்கிரீன் கொஞ்சம் பெருசாகும் சார்.
Yep.
ஃபங்க்ஷன் 5
Yes,
மேல
sir.
அந்த எஃப்ஐ ஃபங்க்ஷன் பட்டன் அமுத்திட்டேங்க சார்.
1 second, sir. Only 1 second, sir.
Okay.
Yeah, only 1 second. I will return back, sir.
Okay.
Sorry. So now it is okay.
Sir, please give the F5 function F5
Yes,
button.
yes, sir. That one only I will use, sir. For F5 only, in my screen it will be show for full screen.
Okay, sir. Okay, sir. So, okay, sir. Okay, sir. It's no problem. You will continue, sir. Okay,
Sir,
sir.
now it is okay.
Okay, sir.
I
Okay,
will.
sir.
Yeah, now I am in the fourth slide, sir. It is
Okay.
visible from all.
So now in the first slide is, sir. We change it to fourth slide, sir.
Okay, okay.
Oh.
I am in the fourth slide only, but what happened? I don't. When I using for F5, it is not come, sir.
Okay,
Only
okay,
for
sir.
this screen only it will come.
Okay, sir. Okay, sir. No, no problem, sir.
Okay. Okay, sir. So I will move on the little bit fast, sir, because everyone is known from this one.
Okay, sir.
Okay, sir.
Okay, sir.
Yeah, yeah. Okay, sir. After that, I will share this file in your WhatsApp, sir.
Okay, okay,
Okay.
sir.
Okay, okay, sir. Thank you. So now I move on to the next one. They having for the column having the bottom, it is fixed, and the top one will be for the free end. So that time you must be using for the recommended value for effective length will be same for one time of the year. So these are the various conditions they will be using for calculating the effective length. So as per your IS 456. Okay, and the next criteria you must be know from the slenderness ratio. Normally your compression member they having for mainly the two types. One is for the short column, another one is for the long column. So how to identify for this one based on this one slenderness ratio. Okay, how to calculate for the slenderness ratio for effective length divided by your dimensions value LEX by here I given us from the two dimension value. One is for LEX by D, another one is for LEY B value. Okay, these values will be from less than 12, then it will be going from the short column, it is greater than 12 is from your long column. Okay, here I given from both the direction. In that IS code book, they given us from X and Y direction. Then they will be set from either less than 12 or greater than 12 for slenderness ratio. And the second next criteria, I will go from the minimum eccentricity. Okay, so the minimum eccentricity here the condition is given from IS 456. That condition is given by unsupported length of the column divided by 500 plus lateral dimension divided by 30. Okay, this is the condition is given from IS 456. So what is that unsupported length? That is the given in the problem for you got to identify from the FT length, and unsupported length is given in the directly. So that value divided by 500 plus your dimension of the column. Okay, your dimension, suppose rectangular is given in your design, you must be taken which one is the least value. That value you must be substitute here divided by 30. Okay, so this value will be for satisfy the minimum eccentricity is 20 mm. Please note it down. For this value will be satisfied for 20 mm. then only your column minimum eccentricity will be satisfied. Otherwise, you revise that your column size. Okay, so this is that one main criteria for minimum eccentricity. And next one for that another criteria is load carrying capacity of the column. So normally we are using from the load carrying capacity. You go to calculate from that your load will be given in your IS 456 for 39.3. That formula is given directly 0.4 FCK AC plus 0.67 FI ASC. So what happened is you must be using from this value only the unknown for AC and ASC. Already you know what is AC, area of the concrete. Okay. And ASC will be taken from area of the street. So once you know this value, then finally you must be find out what is the your load carrying capacity of the column. And another one more thing you want to calculate from additional moment. Okay, in the same your IS 456, you want to calculate from your additional moment calculation. What is that additional moment calculation? Because of the column they having for the three types of the loading condition. One is for uniaxial, second one is for axial load, another one is for biaxial load. Okay, so when that axial load, there is no problem. There is no movement will be occur. But when you go from uniaxial or biaxial, at that time you must be calculate for additional moment calculation. Okay, so you know very well for that your uniaxial is nothing but your load will be adding some eccentric distance either in x or y direction. That is called from uniaxial. But biaxial is opposite. Okay, the load will be acting from both the direction, x and y direction. Therefore, you want to find out for the moment. That is called from the additional moment value. Here in that IS code 39.7.1, they given in the directly for additional moment in x direction, PUD divided by 2000 LEX by D the whole square. The D is nothing but the depth of the section and B is nothing but the width of the section. So you must be calculate for easily additional moment calculation. This is the one criteria for calculating load carrying capacity. And next one for reinforcement detail. This is that very much needed for you must be draw the reinforcement detail diagram. Okay, for this one will be mainly used for in the construction also. Okay, when you go for the design, for reinforcement detail is very much needed. Okay, for in your IS 456 they given in the clearly they having for many numbers of the criteria is given for the calculation of reinforcement detail. The first one they given us your minimum reinforcement will be taken from not be less than 0.8 percentage of cross sectional area. Okay, but another one condition is given for it is not taken from more than 6 percentage of the cross sectional area of the column. Why? Why they given us that not less than for 0.8 minimum reinforcement is no problem, but they given us not more than 6 percentage of the cross section area of the column. Suppose when you go for design of column, that time no one should using for up to 6 percentage. They will using for up to 3 or 4 percentage only. Okay, here the note they given in that the point in the bottom they given usually not exit 4%. Why they don't consider for 6 percentage of the cross section area? Because of suppose when you go to design for your one structure for G plus 2. Okay, so they having from your height of the building they having more than 16 the height of the building is 16 meter, but in that available market the steel is only for 12-meter length. So you want to connect another one, your vertical rod. Okay. You must be connected from another one vertical rod that is called from the lapping. That is called for the lapping. Okay. So the lapping only you must be using from this criteria one will be satisfied. Okay, already you know very well about the lapping. I think everyone is know what is lapping. Okay, because of you must be connecting from one rod and another rod one will be from tie up from this two. So what happened normally you are designed from 4 percentage and top of the rod will be connected to the bottom rod. So finally it will become from the 6 percentage of the your total cross-sectional area of the column. So the first criteria is mainly used for the lapping of the column. Okay, when you come from the point C, your longitudinal bar, normally your longitudinal bar, they having from the different type of the shape of the column. Suppose you are using for rectangular shape, minimum your number of reinforcements should be 4. But when you come from the circular column, the minimum number of reinforcement will be taken from the 6. Okay, this is the main another one. And next one will be taken from the main bar will be not be less than for 12 mm diameter. When the column detailing, your main diameter is taken starting from 12 mm, not less than 12 mm. Okay, this is that another one point. Okay, when you go from the helical reinforcement, at least you should provide the 6 numbers of the longitudinal reinforcement. Okay, at least you must be provided for 6 numbers of longitudinal your reinforcement. But what happens is your helical reinforcement all are will be in the pacing of equal distance. All the 6 numbers that will be for equal distance. Okay, this is the main criteria from that the point F. And another one more thing that will be taken for the spacing. So normally in the column, your spacing is not greater than 300 mm. So these are the details they given in your IS 456 39 for 26.5.3. They given directly. Okay, so when you go from the construction site also, they will be following for the reinforcement detail like the same thing. And transverse reinforcement. The first one is for longitudinal, and second one we will go from the transverse reinforcement. Okay, so the transverse reinforcement, the mainly you must be considered for the 2 point. One is for the pitch value, another one is for the diameter of the value. So the pitch value normally you must be taken from your the first one is from taken by the least dimension value. The first point you must be taken for least dimension value. Suppose the rectangular section they given by 200 by 300, you must be taken for 200 mm. Second one, 16 times the smallest diameter of the longitudinal reinforcement bar. That means you must be multiplied by 16 into what is the your main reinforcement diameter, you go to multiply. Suppose I am using for 12 mm dia, so 16 into 12. That is that another one value. Finally for 300 mm. So compare with all the three, which one is given for the minimum value? That is for your pitch value. Okay. And the second one for the diameter. So what is the diameter? You must be using for the transverse reinforcement. For in your IS 456, they will be put the wrong from here. Okay, they put the from wrong from here. They mentioned as 16 mm, not in for 16 mm. That is for 6 mm. Okay, so please note it down. How to calculate from this one? That value will be taken from 1/4 of the diameter of the large for the largest longitudinal bar. Okay, here you are using for 12 mm dia. So 12 into you to multiply by 1/4. What value you must be got it, but your minimum your transverse reinforcement will be chosen 6 mm. Okay, so this is for your for your transverse reinforcement. Another one is for how to arrangement for your transverse reinforcement. Okay, so here actually the my graphical pad that having some problem. Otherwise, I will draw from here. I will mark it from the diagram. Okay, I will try one time. It is possible. I will try. All right. Okay. So here you must be taken from. Suppose I draw from diagram here. Okay. The number of rod is I given 1, 2, 3, 4. Like I given like this. Okay. So the distance between the two rods is having for less than 75 mm. Okay. Suppose that having for given us less than 75 mm. So what happened? You must be provided the transverse reinforcement in alternate bars. Okay. For both vertical as well as horizontal. Suppose I will put from here, right? So here I will put from here, another one rod from here. So you must be placing from that your transverse reinforcement should be provide alternate reinforcement like this one. Okay, for vertical. Here also for alternate reinforcement you should provide from here. At the same time for horizontal also you should provide alternate reinforcement. You should provide the link from here. Okay, so this is the condition is given for when your spacing between the two reinforcement is less than 75 mm only, you should provide the transfer reinforcement from alternate for the text. Okay, this is that one more thing. And another one more thing they given from the transfer reinforcement, your longitudinal bar spaced at a distance not exceeding 48 times the diameter of the type. So what happened? So this is another one diagram. I will mark from here. Okay, this is I go to mark from here. This is the corner of the rod. I given like this. Okay, and another one I given. So what happened? Your launch roll bar spaced at a distance of not exceeding 48 is the diameter of the bar. That means you must be provide your closed loop and open loop. You should provide like this. For vertical, you must be provide from like this, and horizontal also you must be provide from your closed for your open link. Okay, for the closed link also you must be using from this one, and from the open links also you must be provide when the condition is not exceeding 48 times of the diameter of the die. Okay, and this is for your practically you must be using from the column size. Please, this is one important thing for thumb rule. Say like that the thumb rule you must be using from the column size. What are the column size? Normally they provided in the site. For here I given from the two types. One is for residential, another one is from the commercial. For the residential, normally they starting from 9 inch by 9 inch, and maximum they will be taken from 9 inch by 2 feet also. But when you come from the commercial, they given us 9 inch by 9 inch will be the minimum, but maximum they given from 1 feet by 1 feet 3 inch. Okay, so this is that value they will be using in the construction site based on your residential type of the building, what type of the building you are using, and how much load will be maximum taken, different type of the floors, then only they will taken for your size of your column. Okay, so this one I given us the both the type, residential type as well as the commercial type. So here the thumb rule they will be using from the construction side. Normally your design as per IS 456, we go to do from loading. Okay, what are the load is given, what are the grade of concrete is given, what type of the steel is given. Then you go to design from IS 456. But in the construction, they don't do the calculation, any calculation. Based on that, they will be taken from the thumb rule. Okay, here I given some example I given. Okay, I want to tell them that is the time is not sufficient. Therefore, I will given for only one type. Then you must be see from the PowerPoint. Okay, for the first one, your distance between the two column is 8 feet to 12 feet. Okay, the distance between the two column is for 8 feet to 12 feet. You must be provide from 9 inch by 9 inch column, having got your the size of your column. Okay, your size of your column will be provided from right 12 dia. Minimum they will be provided for 4 number. This is the they will provide from your distance of the column will be 8 foot to 12 feet. Suppose when you go from the distance 12 feet to 6 feet, same 9 inch by 9 inch column, they will provide from the 6 number. Okay, they will provide for 6 number 1, 2, 3, and 1, 2, 3. Right, they will provide from the 6 number for 12 dia. At the same time, they will be using for distance of 16 feet to 20 feet. Then you must be provided your column size will be from 9 inch by 1 feet column with 6 numbers of 6 number dia, or they provide from 4 number 6 number dia and 2 numbers of 12 dia. Please all of you see that the third one, the third condition from your 6 numbers of 6 dia that will be equal to 4 numbers of 6 dia and two numbers of 12 dia. Okay, both are will be equal, right? So this is for your thumb rule. They will be using from your construction side. And next one is that orientation. Okay, so this orientation is mainly important for the construction side because how the column will be placed either for x direction or y direction. How they will be identified. Okay, based on your that length value only they will be considered, because if the length will be for your distance will be more, so your moment values also give that height. As the moment will be high, what happens? The bending also high. So you want to resist that moment value, you must be provide your orientation along that direction. Here I given some mark value 1, 2, 3, 4, 5, 6, and 7, 8, 9. Here I given for even I given for one example how to they will be placing for orientation from the number 1. Okay, this is the corner column. Number 1, 3, and 9 and 7 all are corner column. How they are placing for the column? Here I will take it from the number 1. For x direction, that value will be for 14 feet. For y direction, that value will be for 12 feet. Okay. So which one given for the maximum value? For x direction for 14 feet. Okay, the x direction for 14 feet. So you must be provide the orientation along the x direction. All of it clear? And next one, I will come from the point. Your point will be from the your exterior of the column. Your exterior of the column. This is the point 5 is the interior of the column, and the 2, 6, 8, 4 all are exterior of the column. So what happened in the number 2 for exterior of the column? How to calculate for orientation? So here they will be connecting for the two beams. If it is all of you see here, they will be connecting for the two beams along from the size of the fourth beam, and this room having for 12 feet. Okay, so but this side they will be having for the vertical from the y-axis they having for 12 feet. Then how to calculate from the orientation? Please note it down. This is for the connection of the two beam for the two room in x direction. This is for 14 feet. This is 12 feet. So 14 minus 12 they given for only 2 feet. But when you come from the y direction, the room size is given as 12 feet. So what happened? Which one is given for the maximum value? That is the 12 feet. 12 feet given the maximum value. Therefore, you should provide the column orientation name along with the y direction. So this is the way you must be provide from orientation. So please, I think everyone is clear because of this is the corner. So the same you go to adapt from here, and this is the your exterior column. How to calculate this one? Suppose when I come from the fifth one, that is the interior column. So the interior column they will be connected from the two beams from x and two beams from y. So you must be calculated for two beams from the two directions. So this one is for 14, this one is for 12. Okay, 14 minus 12 they given for the 2. And same you must be provided from here. Y-axis, this room having for 12 and this one is for 16. So 16 minus 12 is 4. So you must be provided your orientation along in the y direction like this way. Okay. Suppose if anybody they having some doubt, okay, sir, it is only this way only you want to provide for orientation. Otherwise we having given for our own way given for orientation. It is possible. It is possible. But what happened in your column layout? At least 10 columns is there. Okay, they having for 10 column. You should provide 6 numbers of column given same direction of the orientation. Please note it down. Okay, suppose in your column layout, they having number of columns 10 number. You should provide at least 6 number in the same direction. Okay, but in the architecture point of view, when you come from the architecture point of view, whether you given for orientation, because in the architectural only they given from the not design, they given from the own only they given. Okay, orientation. So what happened that time? You must be increase the your steel capacity. Okay, then only you are resisting even load carrying. So you must be provided for the orientation along from the architectural point of view. So this is the way you must be know from the column detailing. Okay. So this is first your given from the some of that your outline from the column structures only. Okay, here next one shall I move on the beam design, and this is all are will be the common. Better only for few times only. Better I will move on some of the thumb rule. Okay, so what is the thumb rule? They will be using for the beam. Okay, because IS 456, if time is there, surely I will go from, I will take in for the beam. But what happens is the time is only for the limiting time, so I will move on the only for the thumb rule. Okay. So when you calculate from the beam width and the depth of the section from the construction side, depending upon the your building height, your building height will be for 3 meter or less value. Your beam span will be suppose less than 6 meter. You must be adopt your beam width will be for 0.3 meter. 0.3 meter. Okay, suppose when you go from the span of the beam is 6 meter to 9 meter, you should provide the depth of the beam is 0.35 meter or 350 millimeter. Depends upon your building height, whether the building height will be for 3 meter or less. Otherwise, the building meter will be 4 meter to 9 meter. They will be used for this type of the thumb rule by using the construction site. Okay, and another one I will go from the basic some basic rule in the construction site. For the minimum size, they will be using for the beam is 230 by 230 mm. And minimum number of your longitudinal bar is 4 number from rectangular. And bottom bar should not be less than 12 mm. Okay. Already I told that from the column also, you must be using for the 12 mm dia. In the column also, you must be provided from the bottom bar, it should not be less than 12 mm. And top bar, you should not be provided from the 10 mm. You must be provided top and bottom in the same 12 mm. That is no problem. But your building having for G plus 1. Okay, G plus 1. At the time, if you want, you reduce that your reinforcement, but don't reduce below the 10 for top bar, because then your farm will be weak in tension. So at least you should provide the maximum diameter of the bar. That's what I will consider as 12 mm in bottom of the bar. And the stirrups you should not provide less than the 8 mm. And another one more thing, the maximum distance between the stirrups is you must be provide 150 mm. Okay, so these are the some details they given from in the construction. Okay, now I come from the slab design. Okay, already you know that the slab as well as the beam, your IS 456, you must be calculated for FD span, FD depth, all are in the same way. Only for your calculation for the deflection only, that will be changed, that given in your IS 456. Okay, and what is the minimum reinforcement? You must be calculated for according to the two types of the grade of the steel, either FE250 or FE415 or FE500. Suppose when you are using for FE250 grade of steel, that your minimum reinforcement should not be less than 0.15 percentage of BAT. Okay, that is your cross-sectional area. That is your should provide minimum reinforcement. Suppose when you go from high grade of steel like FE415 or FE500, you should provide the 0.12 percentage of BD value. This is for minimum reinforcement. And another one, maximum diameter you must be taken from 1/8 of the total thickness of this as per your IS code. Okay, now, so this is for the slab value and reinforcement detail. For the reinforcement detail for the slab, they having for the two types. One is for the one way, another one is for the two way. For one way slab, okay, your one way slab, your main reinforcement should be provided only in the shorter span, because the maximum movement only taken from the shorter direction only. Therefore, you must be provided the main reinforcement along the shorter direction and distribution reinforcement provided in the longer direction. When you come from the two-way slab, your main reinforcement should be provided in both the directions, for your shorter direction as well as your longer direction. Okay, so this is for reinforcement detail, and please note it down. So before I start your our delayed class, okay, I will inform you three types of the code book is necessary. One is for IS 456 for design, and next one is for IS 13920. This IS 13920, they given for detailed drawing for all the type of the structure like beam, slab, and column and footing also they given. So you refer that IS 13920 only, you must be provide this all the diagram, how to draw the bending of the native bending, how to provide from the crank value. Okay, because in the end of the support, you should avoid the native moment value. You must be taken for the bend up bar. Okay, how we get from this one? As per your IS 13920 only, you must be draw this diagram. Okay, and next one for the slab, you must be go for the minimum thickness of the slab they given us. Okay, these values are they given. So I don't know that. So I want to move on. The next one is for the foundation. Okay, only some important points only I give for the basic design of foundation. Normally, your width of the foundation and depth of the foundation minimum you should provide 1 meter height. Okay, 1 meter. Both sides you must be given from width and depth should provide 1 meter. Don't get it from below 1 meter. Why? Suppose if you want to put below 1 meter, what happens? Your loading shear value will be happen. Your shear failure will occur in the soil. Okay, if you given for less than 1 meter, so what happens? Your structure will get it from the slippage. Okay, so to avoid that one, so the shear failure will occur. To avoid that one, at least you should provide 1 meter width and 1 meter depth of the foundation. And another one more thing, the footing value. The footing value minimum you should give it as 400 millimeter. Okay, the minimum your depth of footing is given by 400 millimeter. Okay, so this is for the main criteria for the basic design of foundation. And another one more thing, already you know that the separate the design for beam and column. Okay, the separate for structural design for the beam and column. Now I want to explain for what is the beam column joint. Okay, normally they have for three types of the joints are there. One is from corner joint, and second one exterior joint, and third one is for interior joint. Okay, I given only one simple diagram, then easily understand what is that your all the type of the structure. Okay, I given go fast. So this is for right? So here I given this is the beam, a column, right? This is a column they given. So how to connect it from the beam column joint? So this is for this side 1, 2, 3, and 4. All are called as the corner joint, and exterior joint 1, 2, 3, and 4. These are our exterior joints, and the center part will be from interior joint. Totally, they will be connected for three types of the joint. Okay, so how it will be connecting from in the construction site? Okay, normally you must be provided from the 4 points. One is from the ties. Second one depends upon your height of the building based on the height of the column and length of the beam. Third one according to zone 3 and zone 4. The last one for the shape of your reinforcement. Okay, here the ties I will how they will be provided from the ties in the beam column joint. Okay, suppose this is for the column and this one is for the beam. Okay, you should provide the ties from here. So what happened in the ties from the column, you should provide from some distance. Okay, some distance you must be provided. But when you come from the beam column joint, your ties will be provided from nearly. Okay, please note it. This is the first point. They will connect it from the beam column joint. And second one depends upon your height of the your column. That is, you must be provided from. Suppose this is for the column, and this will be connected from the beam. Your height of the column will be taken from, suppose I given as 4 meter. Okay, suppose I will taken from 4 meter of the column height. So what is the width of the section? The section they given as minimum you should provide that value for your width will be taken as 300 mm by 300 mm. You should provide. Okay, this is for your that value. Okay, this is the second point. And third one is from according to zone 3 and zone 4. Okay, for zone 3 and zone 4, you should provide from minimum your beam column joint. The size of the column should be provided 12 inches. Please note it down. When the beam column joint, according to zone 3 and zone 4, the column size at least you should provide. The minimum size you should provide 12 inch by 12 inch. Okay, that is another important thing. The last one is L shape. Please everyone see what is the meaning of that L shape. Same the diagram. I will connect from the beam column. Your top reinforcement. Okay, I draw from here. The top reinforcement come from the beam. Then finally it will be end of your corner point. So it will be bent like this. Okay, like the L shape. At the same time, the bottom reinforcement will come from like this. Then finally it will be connected from the end of your column. Then it will be moved on the top of your L shape. Okay, this is part that is called from the development net. Okay, that's what I given one separate one slide. The given for the development net. So this diagram you must be easily understand how they will be connected from the development net. Okay, the previous I will tell you this is the top rod that will come to up to the end of your column. Then it will be bent like this. Okay, here this will be bent like this. This is called for the development net. Same that will be given from the bottom also. Okay. So how to calculate from the development length? Already you know that from your IS 456 easily calculate for your development length. Okay. That formula is there. You must be calculate for how to calculate from the development length LD. This values are given in your IS 456. 4000 divided by 5 into sigma SD. That is the bond strength between your concrete and steel. Suppose if you are not provide the development length, what happens? Your steel that will be comes out to the concrete. The slippage will be formed in the structure. Why? Because the load will be acting more. So what happens? This is not go for the failure in the steel. First, the steel will comes out to the your concrete. Okay, that will be comes out to the concrete. So the bond will be not happen from the steel and concrete. Okay. So this will be mainly for connecting for your steel and the concrete. That's what you must be provided from development. Okay. So finally, now I will move on to the bond bending schedule. Okay. For bond bending schedule, normally you must be having for the four types: the diameter of the bar and length of the bar, and second one weight of the steel bar. The last one is the hooks. Okay. How to calculate from the bar bending schedule? Normally the first one is the diameter bar. These are the your diameter bar is available in the market. for 6 mm and 8 mm mainly they will be using for the stirrups and ties, and 10 mm, 12 mm, 16, 20, 25, 28, 32 and 40. So this will be using from your bridge structure, and 16, 12, 20, and these are mainly used for the residential normal building structure. They will be using for this type of the diameter of the bar. Okay, and second one, your diameter of the bar, your available market, the one length of the steel bar is 12 meter. Okay, when we go from buy the steel in market, they given us the one length of the steel bar is 12 meter 20. Okay, and the next one is for how to calculate from the diameter of the bar. Normally, you must be already know that your weight will be calculated by using the formula d square divided by 160. Okay, this is the formula you must be using for calculating for the weight of the steel. So this is the formula for kg per, in the terms of unit is kg per bar. Suppose you are using for 8 mm dia. Okay, suppose you want to use it for 8 mm dia. So you go to substitute for 8 from here, 8 square divided by 162. So that value you go to multiply by your length of your stick. That is a 12. Then only you must be calculate weight in grams of kg per bar value. This is the calculation for your diameter of the bar. Okay, and the last one you must be having for the hoops. Okay, just what is the function of the hoops for your stirrups and from the ties? Okay, you are using for the hoop. What is the function of this hoop? Mainly, they will be prevent for the seismic movement and slippage for the steel and concrete. Okay, already I told that the second from the development and the third one will be for your bar will be in the same position. Okay, that's what they will be given from the tight value of the hoops will be provided. So these are the some details they given in your code book as per your IS 436, and from the construction site, what are the details are given. Okay, if the time is permitted, I will move on with some of the criteria. For one is from I given us how to calculate for the quantity of steel for the slab beam, putting in column. This is for the thumb rule they will be using for easily calculation for the quantity of steel for the slab beam, putting in column. Normally slab, for here I given only one first choice I given. Slab is considered from 1% of steel for total volume of concrete. Then how to calculate from the weight? Your weight will be calculated from your density of steel multiplied by volume of concrete. Okay, how to calculate from the volume of concrete? Because I consider from the one room having the size and thickness of the value. Your thickness of the value for the slab is considered as 125 mm. So what happens? You have to multiply by the room size, multiply by the thickness of the slab, you get it from volume of concrete. So this value you go to multiply by density of steel, that is 9850 kg per meter cube. You must be getting from your weight of steel. Okay, so these are the some of the your details they given from IS 456 and your construction site what they are using for thumb rule. Okay, now so hello everyone, everybody is there.
Yes, sir.
Okay, sir. Sir, it is okay.
Oh, okay, sir. Thank you for the wonderful
Okay, sir. Anybody having doubts, sir?
participants. Anybody having queries? Just put the chat box or otherwise unmute your mic, then directly ask.
After my lecture, then I will forward this PowerPoint to the students. I will send it to you. You just forward to the our students or faculty.
Oh, okay, sir. Sure.
Okay, sir. I give my mail ID also. If anything having doubt, they will communicate in my mail ID also.
Oh, okay, sir. Sure.
Okay. I think no doubt. Okay, sir.
Oh, okay, sir. Oh,
Okay.
someone asked 1 second orientation. This video in the YouTube also. I had sent this links. Please watch again the orientation of this. I think this video is in this YouTube also. Please watch again.
Yes, thank you. Yeah, thank you. Thank you.
Okay.
Thank you, Mr. Udit Shankar. Thank you very much for giving this opportunity.
Thank you, sir.
Okay. In the future onwards, I am very much eager to come and deliver the class. Okay.
Sure, sir.
Yeah. Thank you.
Thank you.
Thank you. Thank you all. Thank you.
Thank you, sir.
Thank
Sir,
you.
I have one doubt.
Lovraj, yeah. Yeah, tell me.
Sir, for earthquake resistant areas, we can provide the strong column or deep green concept. Is there any
Yes,
criteria for using the, for example, if we want to construct a column beam, is there any criteria, sir, for constructing
no, sir.
earthquake
No, no.
resistant zones?
No. As per your IS code, they given us 875. They mainly, particularly, they given for earthquake resistant design. Okay. For the stock column and deep green design, they given in the directly. Okay. If you want specify, then I will show that diagram. I will take, then I will forward to you.
Yeah, okay, sure,
Okay,
sure.
they having for different 5 points they given. Okay, then I will give
Okay,
that
sir.
particular points, then I will give it to you.
Okay, sir. Okay.
Okay.
Okay, thank you, sir. Thank you.
Okay, fine.
Uh, Thank
Okay.
you, sir.
So thank you for one more. I thank you everyone. Thank you for attending this meeting. Thank you, sir. Thank you.
Participants, please fill the attendance form. I will put in the chat box also. Please fill it for the duration. It's the cross check with your name also. Attendance and names will cross check. Only you will give the certificate also. I take the screenshot from your names. Then I cross check with your name and attendance sheet. Then you will be provided the certificate for who can attend the 6 days. You will provide the certificate also. Okay. Once again, thank you all. Sir, please leave the section, sir.
Yes, sir. Thank you, sir.
Thank you. You fill the feedback form. You will be leave this section. We will meet on tomorrow. This video will be available on YouTube channel also. You will watch it.